Welcome to this Spirent presentation on multi-protocol label switching, or MPLS. This presentation will give you a quick introduction to the MPLS protocol, how it's structured, and the common terms used. If you'd like a copy of this presentation, please visit my wiki at allentestwiki.pbwiki.com. For additional information on Spirent products and how we can help you with MPLS testing, please visit our website at www.spirent.com. Here is some of the terminology that is frequently used within MPLS. For example, FEC, Forwarding Equivalence Class, a group of IP packets which are forwarded in the same manner, for example, over the same path with the same priority and the same label. Label, a short fixed length identifier which is used to identify a FEC, or forwarding equivalence class. Label swapping, looking up the incoming label to determine the outgoing label, encapsulation and port. As you'll see, there is no end-to-end significance with the label values that are used in MPLS. Label switch path, or LSP, a path through one or more label switch routers for a particular forwarding equivalence class, or FEC. LSR, or label switching router, an MPLS capable router. MPLS is a layer 2.5 protocol. It sits between the MAC layer and the IP layer. It is a very useful protocol, allowing carriers to establish virtual private networks across large public networks. This technology can also be found deployed in large enterprise networks. MPLS allows groups of users or applications to be grouped together within one label and provide, if required, their own separate service agreements, or service level agreements. In addition, by encapsulating the data within the label, you are effectively isolating these users or applications from other traffic running within the network. The label is referred to as a shim and comprises of 32 bits. The first 20 bits are used to uniquely number the label. As will be shown, this has no end-to-end significance. The next 3 bits are known as the experimental bits and are used to indicate the quality of service or priority of the label. It is possible to have multiple labels stacked on top of each other. The 1-bit bottom stack flag, or S-bit, is used to signify that the current label is the last in the stack if it's set. Then finally we come to the TTL, or time to live. This basically serves the same function as in IP and will stop the packet or the label going into an endless loop if the TTL is decremented down to 0. A number of different protocols are used to set up these labels. 2 of the most popular are LDP, the Label Distribution Protocol, and RSVP-TE, the Resource Reservation Protocol with traffic engineering. Labels may also be manually configured by the network operator. Shortly I'll be posting other videos on subjects covering 6PE and 6VPE, so as you'll find out, there are in addition other label technologies which can also be used. Here we have an example of how a packet moves across a VPN implemented using MPLS. The packet enters the ingress router. The label, with a value of 40 for this example, is pushed onto the frame between the MAC and the IP layer. The label travels to router 2 and is swapped for a new value of 45 and is directed to router 3. Router 3 is a penultimate hop router. It is frequently the job of this router to remove the label. This helps reduce the load on the egress router, as it may have to remove the labels from many other different sources. The packet can now be directed to the egress router R4 for final delivery. Thank you for watching this Spirent presentation on MPLS. If you would like additional information on Spirent products and how we can help in testing these types of networks, please visit our site at spirent.com. Also, if you would like to view more technology videos, search YouTube with Alan Talks Tech. To get a PowerPoint copy of this recording and many other presentations, please visit my wiki at alantestwiki.pbwiki.com. Once again, thank you for viewing.